Launch roller coasters are far more thrilling than traditional lift hills. More recently, roller coasters have been popping up all around the world with a new type of launch idea: swing launches. A famous example is the transforming of Top Thrill Dragster at Cedar Point into Top Thrill 2, featuring that swing launch system and a new 420-foot spike. While most of my model roller coasters in the past features a lift hill, I have built a few with a launch. I thought it was a good idea to take it that next step forward and attempt to build a roller coaster that uses a swing launch to get to its top speed. Another system I will have to recreate is a switch track, which is something I've never attempted before in my model roller coasters. So let's get started. I made a simple station in a small part of the brake run and made a curve to where the switch track would be. Since CDX uses tubes and cross ties to make its track, it was hard to finesse the switch track in a way that it can connect up cleanly to both the station track and eventually the launch track. I would eventually run into problems with it in the future, but it does get solved. I build the supports for a spike and work on the launch track, which will have a small bunny hop at the end. This coaster is going to be based off the intimate multi-launch coaster type, and I'm planning on giving it a really cool top hat like the one on Pantheon in Busch Gardens, Williamsburg. For this video, I'm just going to be working on the swing launch portion of the layout, and I'll finish the rest of the coaster in the next one. So here's all the track that's done for now. It's looking really cool, and I really like the extra angular supports on the top hat. This looks like a really intense element that would deliver a lot of great airtime going over the crest of the hill. Here's how the switch track is going to work. Basically, this gear here spins and extends the rack. I can connect a motor here and easily code it to the EV3. I just need to work on lining up the track so that the train flows smoothly, transitioning in and out of the switch track. You can hear this little clanking sound, which means that the track is misaligned a little bit and it's slowing the train down. So I need to figure out how to reduce that as much as possible. Unlike my other launches, this launch will use a drill. This is the smallest drill I could find, and it spins really fast. I made sure that the train can get over the top hat with the top speed of the drill. One of the hardest parts of this build was figuring out a way to both trigger the drill to turn on and control the speed of how fast the wheel is turning. Not only that, but I was also limited on how many motors I can control with the EV3. EV3s have ports that can only control up to 4 motors at maximum. I know I will need one motor for controlling the switch track, and one for getting the train its initial push onto the launch track. This means that I will only have 2 motors that will control the drill for the actual swing launch. This is the design I ultimately came up with for the drill. It's not my proudest work, but it does get the job done. Basically, this motor spins a pulley attached to a string around the trigger. When the pulley spins, it tightens the string and compresses the trigger. I can control how much the motor spins, which can control how fast the wheels go. I connected this to the launch track and made sure there was enough room for the train to contact the wheel. This is how I plan on the swing launch working. My swing launch is obviously very different from real-life swing launches. While real-life examples of swing launches use LSMs to speed up the train, I'm going to be using a very fast flywheel. My launch is more of a pseudo swing launch, because how swing launches usually work is that the LSMs launch trains forwards, backwards, and then forwards again. However, mine is going to be different. Since I have a limited amount of motors, I can't control the drill spinning in different directions. So I'm not going to be launching the train backwards. Instead, I'm just going to be moving the flywheel out of the way and letting the train roll backwards up the spike. Then after the train comes down the spike, I will put the drill at full speed, which would launch the train over the top hat. I'm now working on the mechanism that will move the flywheel out of the way. It's really similar to the switch track, where a chassis is riding on wheels. I'm going to be using Lego's train track pieces and train wheels to move the drill and the flywheel away from the launch track. I will also be using a rack and pinion connected to the coaster's third motor, just like what I did on the switch track. Building it was pretty straightforward, but I had some trouble strengthening the chassis. The drill was very heavy, and sometimes the supports holding the heavy drill up would snap under all the weight. And I also had some trouble finding a long enough cord so that the drill can both be controlled and moved without messing with the EV3. Here I put everything together and put the drill on the chassis, and you can see how it will move. All I now need to do for this is make sure the wheel is lined up to the track and put down stoppers so that the chassis will return to the correct position. The rack and pinion doesn't need to move this far, it just needs to move so that the wheel is out of the way. I put all that stuff together here, and strengthen it up. Finally, I hooked it up to the EV3, which let me give the coaster its first initial tests. I strengthened this back rack even more, and I was excited to do even more tests. Now I want to work on automating the full coaster. On those tests, I was still pushing the buttons on the EV3, but I want to get this coaster to a point where I just need to push a button that'll start a program and it'll do everything for me. Let's put the motors on the switch track and build a little spinner that'll give the train its initial push into the flywheel. Here's everything connected up to the EV3, so all I need to do now is code it and run some tests. Coding this thing was probably the most time-consuming part of the whole build, and it led to a lot of failed attempts. So I'll try to describe what the coding part of this coaster was like. First off, I wanted to get the switch track done. Basically, I was just having the motor move very slow and use trial and error to get the track lined up correctly. Sometimes the track would get stuck on the launch track and not completely move into place properly. When this happened, I would have to go in manually and adjust the ends of the launch track and the ends of the track going up into the spike so that the edges don't clip the moving switch track. Next up, I coded the spinner, which was pretty straightforward, as well as the first sequence of the drill launch. I'm not worrying about all the timings right now. I want to get all the motor movements in before I have to do the tedious part of fixing all the timings. Here, I start getting the train involved, and I make it so that all the code is running together. The timings are still definitely off, and this is where I start fixing that. I start structuring the code by the sequence, which just makes the code much more organized and easier to understand. While I fix the timings, let me explain all the sequences of the swing launch. Firstly, I want to get the switch track to take the train and connect to the launch track. Then it'll start the launch sequence by speeding up the drive tire by 75% full power. Then the bar will spin and push the train into that first launch. Once the train is clear, the tire will move back and let the train roll back into the spike. Then sequence 3, the drill will go to 100% speed and move back into position, launching the train for a second time over the top pad. Then the drill will turn off and the switch track will go back to the station to pick up the train again. All of this would happen in less than 10 seconds. From now on, I'm just working on the timings and fixing any bugs that pop up along the way. Here I noticed that the track is starting to get misaligned, which is slowing the train down when it goes into the spike. I eventually fixed this problem by tinkering with the track alignment later on. I had a weird problem where sometimes the code would skip over a step, but continue on with the launch sequence. This will happen a lot with the moving parts of the drill and the spinning bar, like right here where the drill doesn't return back to its launch position. I don't think my code was wrong. My leading theory is that the coding engine I use is just really outdated because it was very unreliable when making this coaster. This would also sometimes happen to the spinner, where the drill will get up to 75% power, but the spinner will never actually activate and push the train into the wheel. Reliability-wise, this roller coaster still has a long way to go. I say the coaster works right now around 60% of the time, and my goal is to just keep improving little things and strengthening components of the launch to get the coaster to the point where it works around 80% of the time. For how complicated the swing launch is, 60% is a pretty good starting point, and it already works better than most of my other roller coasters launches, and we're still really early into the building process. Attempt 38 is the first time that the code worked. There are still some things to fix, like that track alignment problem again. I'm going to clean up some of those problems off camera, so enjoy the final test runs of the video.